Hello everyone and welcome back to my YouTube channel. I'm Naina Priya M from CSE AI department. Today's subject is discrete mathematics structure and the topic is the laws of logic and logical implication. The fundamental principles of logic form the backbone of mathematical reasoning and discrete structure. Understanding how logical rules and implications operate is essential for solving complex problems and deriving valid conclusions. Fundamental principles of logic. Firstly, clarity. Precisely defining terms and concepts to avoid ambiguity. Secondly, consistency. Ensuring statements do not contradict each other. Thirdly, validity. Ensuring the logical reasoning follows sound rules. And lastly, soundness, verifying that the premises are true and the conclusion follows. Propositional logic and logical connectivities. Firstly, conjunction, that is, and logical operator, combines two propositions, both of which must be true. Disjunction or combines two proposition where at least one must be true. Negation, not, reverses the truth value of the proposition. Logical implication and equivalence. Implication. If then, a logically valid inference where the truth of the premise guarantees the truth of the conclusion. Equivalence. If and only if a logical relationship where two statements have the same truth values, that is, they are either true or both false. Contraposition. The logical equivalence between if P then Q and if not Q then not P. Logical validity and soundness. Validity. A logically valid argument ensures that if the premises are true, the conclusion must also be true. Soundness. A sound argument is both valid and has true premises, guaranteeing a true conclusion. Whereas invalidity. An invalid argument may have two true premises, but the conclusion does not necessarily follow. Unsoundness. An unsound argument has at least one false premise, even if the logical reasoning is valid. Logical inference and deduction. Premises. The set of statements assumed to be true and used as the starting point for logical reasoning. Rules of inference. The valid logical rules that allows drawing new conclusions from the given premises. Conclusion. The final statement derived from the premises using the rules of inference. Logical paradoxes and fallacies. Liar paradox. A self referential statement that leads to a contradiction. Russell's paradox. A paradox about the concept of a set of all sets that do not contain themselves. Slippery slope fallacy. Assuming that one event will inevitably lead to another without justification. Ad hominem fallacy. Attacking the person making an argument rather than addressing the argument itself. Applications of logical reasoning in discrete structures. Computer science. Logical reasoning is essential for algorithm design, data structures, and software verification. Cryptography. Logic is used to design secure communication protocols and analyze the validity of encryption schemes. Combinatorics. Logical reasoning is crucial for solving counting problems and enumerating discrete objects. Limitations and challenges of logical systems. Undecidability. Some logical statements cannot be definitely proven true or false. Incompleteness. Logical systems may not be able to prove all true statements within the system. Paradoxes. Logical paradoxes highlight the inherent limitations and contradictions within logical reasoning. Subjectivity. The interpretation and application of logical rules can be influenced by individual biases. Conclusions and takeaways. The laws of logic and logical implication form the foundation of discrete mathematical reasoning. By understanding these principles, we can construct valid arguments, identity fallacies, and apply logic thinking to solve complex problems in various domains. Thank you. Please do like, share, and subscribe.